Today we will be graphing cardioids and limacons. A cardioid is a little bit heart-shaped. I think of it like that. It has that cardio kind of prefix going on in there. It's a little heart-shaped, and you can see they are a little heart-shaped. Okay, they're nice and full and round hearts. They're not skinny hearts. They're not cutesy hearts. A limacon is also a little bit heart-shaped, but limacons, there are two types of limacons, those with a little loop and those without a little loop. Okay, so we will learn today how to distinguish between these two in their equations and in their graphs and how to graph them. All right, first of all, cardioids. A cardioid has this equation. Okay, we're still dealing with sine and cosine. Has to be a single theta here. Okay, not a 2 theta, 3 theta, 4 theta, etc. Has to be a single theta. Okay, and we see we still have a number out in front of the cosine or sine, but we also have another number being added or subtracted in the front. Okay, for a cardioid, these two numbers are the same. Well, their absolute values are the same. They can be positive or negative, but if their absolute values are the same, you have a cardioid. Okay, cardioids are heart-shaped. Always go through the origin. Make your cardioids nice and plump. Okay, and I have this written just for those who want to read what I'm saying, but I'm just going to do this with some examples how to graph them. So first of all, we recognize, oh, this is a cardioid. Okay, this is a cardioid because these two numbers have the same absolute values. Okay, it's also a sine cardioid. If it's a sine cardioid, I know that the bulk of it will be on the positive, well, it will be on the y-axis. It'll be on the positive y-axis because of that plus sign in front of the sine. So I think to myself, plus sine means plus y-axis. The bulk of this will be on the positive y-axis. How far up on the positive y-axis? You add these two absolute values. So 6 units up. I'm going to go 6 units up. 1, 2, 3, 4, 5, 6. I'm 6 units up. Okay? And now I think to myself, how far side to side do I go? Well, this front number, the absolute value of that front number tells you how far to go side to side. So 1, 2, 3, 1, 2, 3, side to side. It is a cardioid, so we go through the pole and we connect this with a nice, smooth, full shape. Okay? We can confirm this on our calculator. Confirm this on my calculator. Still had yesterday's roses up there. This is 3 plus 3 sine theta. It's going off the graph a little bit, but there you go. Okay? All right, next up. Here we have another cardioid because the absolute values are the same. 2 and 2. Negative cosine. Negative cosine, so negative x-axis. Think that on these. Negative x-axis. How far negative x-axis? Add these two numbers. 1, 2, 3, 4. 2 plus 2 is 4. That's how far you go out on the positive x-axis. The bulk of this will be on the positive, negative x-axis. Sorry, negative x-axis. Okay? How far side to side do you go? Well, this number here tells you how far side to side to go. 1, 2, 1, 2. It's a cardioid, so it goes through the pole, and we connect these with a nice, smooth, nice, smooth, full curve. Something like that. Okay, I'm pretty shocked that that one looked as good as it is. Usually mine don't look that good. That's more like what I usually look like. Okay, that's all right. Again, you'll not be graded on your artistic abilities. Okay, all right. So what I see here is I see a negative sign. If I see a negative sign, I know the bulk of this will be on the negative y-axis. So negative y-axis, how far on the negative y-axis? 4 plus 4 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Feel free to go off if the axes aren't long enough. Feel free to go off if you want to. Okay, how far side to side? This number tells us how far side to side. 2, 3, 4. 1, 2, 3, 4. It is a cardioid, so we go through the pole. And we try to connect these with a nice, smooth, plump heart. Something like that. Okay? All right, let's make the equation for this one. So the first thing I see is that it is a cardioid. It is a cardioid, and the bulk of it is on the positive x-axis. So I know it's going to be a plus cosine. I know it's going to be a plus cosine. Okay? And I know it has to be just a theta. These are always just theta. If it's not just a theta, it makes a different graph altogether. Okay? All right. Now, I like to go and get this number out here first. So how far side to side did I go? 1, 2, 3, 1, 2, 3. I went side to side 3, so this has to be a 3 there. So now what do I add to 3 to get out here? I go 1, 2, 3. How many more do I add? 3 more. Oh, well, this is a cardioid, so I should have known that. They'll both be a 3. Finish it with an r equals to make an equation. If you don't have the r equals, it's not an equation. It won't be right. Make sure you get that r equals. Okay. All right. Oh, what happens if the theta coefficient is not? What if it looks like a cardioid here, but it's not just a theta? It is not a cardioid at all. It resembles more like a rose than it does a cardioid. But it's not a rose. I know it's not a rose because it goes over the y-axis right here. Okay? You do not need to know those graphs. I'm just saying what happens if it's not. You can play on your calculator with these. They do really make some amazing graphs. I love just fiddling on my calculator, making some graphs. Okay? All right, so those are the cardioids. So what happens if these numbers are not the same? So what happens if they are not the same? Well, there are two types. Then you don't have a cardioid, you have a limason. A limason. Okay? So we have two types of limacons. Limacons without loops and limacons with loops. Looks like we're going to do the without loops first. So without loops. The ones without loops are when this number is larger than this number. Okay? So you know they're not going to be the same, because if they were the same, it would be a cardioid. Okay? When the absolute value of this number is larger than the absolute value of this one, you have a limason without a loop. Okay? I like to think to myself, if this first number is bigger than this number, then your limason will be bigger than the origin. It goes outside the origin. Okay? So let's look at how we would graph this. The first thing I see here is a negative sign. So I know the bulk of this will be on the negative y-axis. Okay? How far on the negative y-axis? 6 units. So I'm going to go out 6 units. Okay? How far side to side do I go? Well, I go side to side 4 units. So side to side 4 units. Okay. This number is larger than that number. So I know it's larger than it does not touch the origin, it's bigger than the origin. So it's further away from this point, it's bigger, so it's further away, okay? How far further away? To get how far further away, you subtract these two numbers. 4 minus 2 is 2, so we go that far out. And then we draw it. And sometimes these are easier to draw than others. Okay, sometimes there will be a little dimple here, just like we have with a cardioid. Sometimes it's more of just like a flat spot, okay? It kind of does a little of each. You see these ones that I drew on Desmos. Some of them just have a slight little dip. Some of them, it's hard to tell that there's even a dip at all there, okay? So I don't care how you draw it, but you do need to show me these 4 points, okay? I need to see all the crucial points, and I need to have a way to find them too. So if you want to do hash marks, do hash marks. If you don't do hash marks, you're going to have to tell me what number this is on, like a 4, a 6, a 2, okay? But hash marks are good because I can count those hash marks. Okay, let's do another one. In this one I have a positive cosine. Positive cosine, so the bulk of this will be on the positive x-axis. What number is in front of that cosine? Well, there's a 1 in front of that cosine. We just don't write it if it's a 1, but there is a 1 there. So positive x-axis, how far out? 3 plus 1. So 4. I go 4 out on the positive x-axis. Okay, how far side to side do I go? Well, I go 3 units side to side. 3 units side to side. Okay, 3 is larger than 1, so it's bumped out away from my big side. How far away from my big side? You subtract these two. 3 minus 1 is 2, so we go out here 2 units. And then we draw our curve. It's going to be hard to make that a dimple, so I just make it like that. That one's going to look more like this one does down here. Okay? But again, if you want to draw it with a little dimple, that's fine. Okay? Alright, let's do this one. Positive sine. So the bulk of this will be up on the positive y-axis. How far up? 5 plus 2. 7. 1, 2, 3, 4, 5, 6, 7. 7 up. How far side to side? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 5 is larger than 2, so we're bumped up. Remember, we're talking absolute values. So 5 is larger than 2, so it's a Limacon with no loop. We're bumped out on the other side. How far out on the other side? 3. 5 minus 2. And then we try to draw this as smooth as you can. With or without a dimple is fine. Okay? Alright, one more of these. Positive cosine. So again, the bulk of this will be out on the positive x-axis. How far out? 9. 9 units out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? How far side to side? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 5 is larger than 4, so we're bumped out on the other side of the origin 1 unit. 5 minus 4 is 1. And then we're going to draw our curve like so. Okay? Alright. Let us now write the equation for each of these. So here's what I'm thinking of for the equation. First of all, I see it's a Limacon without a loop. are equals. Okay, limacon without a loop. The bulk of it is on the positive x-axis, so I know it's going to be a plus cosine. But let's get the numbers. Okay, let's get our side-to-side number. Our side-to-side number is 1, 2, 3. Our side-to-side number is 3. Okay, now what do I add to 3? What do I add to 3 to get out here? Here's what I do. I go out 3 and I count. How many more does it take to get to my end? 1, 2. It takes 2 more. And then I'm going to have a cosine theta. And that'll do it. Let's do this one. Okay. How far side to side do I go? 1, 2, 3, 4, 5. 5 side to side. Okay. I'm on the negative y-axis, so I know it's going to be a minus a sign, right? But it's going to be a minus here. And now what number comes next? I count. 1, 2, 3, 4, 5. That will be this 5. How many more do I need? 1, 2, 3. Okay, not bad. Let's do this one. This one hardly looks like a limacon, but it is. I know it is because it's the only one that I know how to find. It's only one of our classics that it's not. This looks, it resembles a circle, but I know it's not a circle, but it does resemble a circle. Okay. Why do I know it's not a circle? This diameter would be 9, and this diameter would be 8. So I know it's not a circle. Okay? All right. How far side to side do I go? I go side to side 4. The bulk of this is on the negative x-axis, so I know it's going to be a minus cosine. 1, 2, 3, 4 will take me out here. I need one more to get out to my end point. Okay, one more of these. How far side to side do we go? 1, 2, 3, 4 again. This time we're on the positive y-axis, so it's going to be a positive sign. What's my next number? 1, 2, 3, 4. That's this 4. I need to add 3 more to get out to the end. Okay. Just an FYI, what happens if this coefficient, the theta coefficient, is not a 1? Then you get some really pretty graphs. Again, they kind of resemble more of a rose than a cardioid limacon. But again, here, if this number is larger than this number, you're still not going to go, you're not going to touch the pole, you're going to go outside the pole, the origin. Okay, what about if you have a loop? So, if you have a loop, limacons with a loop. How are we doing on time? Oh, we're doing good on time. Okay, excellent. Okay, limacons with loops. Okay, well, your limacon will have a loop if this first number is littler than this number. If it's smaller, the absolute value. If the absolute value is smaller. Okay, I think to myself, if this number is little compared to this number, if this number is little, you have a little loop. It's a cute little loop. Okay? All right, let's see how we graph this. All right, first of all, I see a positive sign. Positive sign, positive y-axis. The bulk of this will be on the positive y-axis. How far up? 4. Okay. How far side to side do I go? 1. Okay. Now, it's a limacon with a loop because this number is littler than this number. Okay. Limacons with a little loop always go through the pole and then they loop up out inside. It'll have a little loop inside somewhere. How far inside? Subtract these two numbers. My little loop will be 2 units long here. Okay, when I graph this, I like to do my little loop first sometimes. Do my little loop. Something like that. This might be a good one to put on our calculator. So we've got 1 plus 3 sine theta. So that's what it should look like, even plumper than what I have it drawn, okay? And the little loop is plump as well. It's not a skinny little loop. You're not going to be graded on your artistic abilities, however. All right, next one. Okay, negative cosine. So think negative x-axis. Right? The bulk of this lies on the negative x-axis. How far out? 3 units. 1, 2, 3. Okay. How far side to side do we go? 1. Okay. 1 is littler than 2, so we're going to have a little loop. Therefore, we're going to go through the origin and bump inside, not outside, inside. How far inside? We subtract these two, just 1 unit inside. Okay? And then we draw this. Okay? So 1 minus 2 cosine theta is drawn like that. Okay, I didn't do too bad on that one. Alrighty. Next one. We have a negative sine. So think negative y-axis is the bulk. How far down do we go? 7 units. So 1, 2, 3, 4, 5, 6, 7. How far side to side do we go? 2. 2 is littler than 5, so we have a little loop. And plug in. Okay, little loop. And so we're going to go through the pole. How long is the little loop? Our little loop is 3 units long. So kind of big. Okay? So remember that these little loops are actually quite fat. So when you're drawing your little loop, you might want to draw it kind of fat. It might also get your curve going the right fatness as well. Something like that. Okay? Next one. We have a negative cosine. So negative x-axis out 7 units. Again, 1, 2, 3, 4, 5, 6, 7. Side to side 3. 1, 2, 3. Okay, 3 is littler than 4, so we're going to go through the origin and bump inside 4 minus 3, 1 unit. So it's going to be a teensy little loop, but it is still going to be fat, so something like that. Okay? Alrighty. Let's see how we get equations if we're given the graph. Okay? So I really clear the Limacon with a loop, right? So I'm going to have R equals, I go side to side. Side to side, how far did we go side to side? We went 2 units side to side. So this first number is a 2. Okay? Alright. We're on the negative x-axis, so I know it's going to be a negative cosine. Let's get the number that's here, though. If I go 2, how many more do I go to get to the end? So I'm just going to count. So I start off with my 2. How many more do I need? 1, 2, 3, 4, 5. I need 5 more. And it will be a cosine theta. Okay? Next up, Limacon with a loop. How far side to side? Well, 2 again. positive y-axis, so I know it's going to be a positive sign. Okay, I go this far, and then what do I need to add to get to the end? 1, 2, 3, 4. I need to add 4 to get to the end. It will be a sine theta. Okay. All right, how far side to side? Just one unit there, side to side. Positive y-axis, so it's going to be a positive sign again. Okay, if I start off with my 1, how many more do I need to add? I need to add 3 more sine theta, and that will do it. Okay. R equals 1 side to side again. This time we're on the positive cosine, or the positive x-axis, so it'll be a positive cosine. If I go 1 unit in, how many more do I need to add? 1, 2, 3, 4. 4 more to add. And that takes care of that equation. Okay, what happens if you have a coefficient that is not a 1 on your theta? Well, then you get a flower-looking thing. They still have little loops, but this time those little loops are inside of your little petals. Okay? They're so cute. I do encourage you to get out your calculator and play with these. You have a lot of fun with it.